All right, here we go. Another math lesson. Today, we're going to be building on our negative number operation skills, but now we're going to be moving on to a special type of number called rational numbers. But instead of being all fancy and using rational numbers, I'll just say rational numbers are all of the numbers in the world that can be written in fraction form. So that actually includes whole numbers like 3 or -15, because you can write whole numbers as fractions, right? Whole numbers can be written over 1. Um, so whole numbers. And I said rational numbers are numbers that include anything that can be written in fraction form. So whole numbers are included. Obviously, fractions are included because they're already in fraction form. And that also includes decimals. For example, let's say 25 hundredths. That can be written in fraction form. That's 1/4. Today, though, we're only going to be doing fraction negative operations. And specifically, we're going to be looking at adding and subtracting positive and negative fractions. So the first thing I'm going to do is go over some key ideas that are actually related to the basics of fraction operations, like without even negatives involved, and then we'll throw in the negatives. So the first thing to remember is no matter what, whenever you add or subtract fractions, you need to make sure you have common denominators. I don't think I really need to go into what that means, but just as a quick refresh, if I had 1/2, whoa, 1/2 plus, well, let's say 2/3. The denominators in this problem are halves and thirds. Those are not common, so I would need to change both fractions so that they had the same denominator, right? I want to be adding two things that are of the same size. I want like sixths and sixths being added together because then everything's the same size. A half and a third are two different sizes. You can't add things that aren't the same size or subtract. Once you have common denominators, nothing new. You're just going to use your normal addition and subtraction rules for negative numbers that we've spoken about. So if it's all whole positive numbers, just add them together and your answer is positive. If it's all negative numbers, just add them together and your answer is negative. If you've got one of each and you're adding, one positive and one negative, subtract the two, and then whichever number has the bigger value, absolute value, that's what the answer will be in terms of a sign, positive or negative. And for subtraction, we don't subtract. The best thing to do to keep it simple for your brain is to change all subtraction to addition by adding the opposite. So change all subtraction problems to addition problems by adding the opposite. And we'll look at an example in here in case you've forgotten what that means. But here we go. First example, -8/3 plus 5/6. I'm adding fractions. Forget that the fact that you've got a -1 in there. No matter what, you have to have common denominators. And thirds can turn into sixths. So I'm not even going to touch 5/6. That's going to stay. I'm going to change 8/3. So I'm going to multiply this fraction by 2 because 3 times 2 is 6. So now I'm going to have 16 over 6. 8 times 2 is 16. 3 times 2 is 6. So 8/3 is going to become 16/6. Now that I have common denominators, when you add fractions, you only add the numerators. Let me do a side example real quick. 1/3 plus 4/3. Your answer is going to be in thirds. We're finding out how many thirds we have in total. Well, I've got 1 and 4, so I've got 5/3 total. So you only ever add or subtract the top numbers. The bottom number, the denominator, just stays the same. So I already know that my answer is going to be something over 6, which means this problem really boils down to what is -16 plus 5. Forget about the sixth part for now. I've got one of each number, one positive, one negative, which means I'm going to find the difference between the two. And since the 16 is the bigger absolute value and it's negative, my final answer is going to be negative. So -16 over 6 plus 5/6 is equal to -11/6. And Typically, the best possible way to write a fraction is you simplify it so that it is not an improper fraction like this, where the numerator is bigger than the denominator. So we're going to write this as a mixed number. How many times can 6 go into 11? 6 can go into 11 one time with 5 left over. Keep the denominator, and my answer is negative. So negative 11/6 is correct. A better way to express that is as a mixed number that is simplified, negative 1 and 5/6. So there's your first answer. Let's look at 2 more examples and then we'll call it a day. The next example, I have eighths added to fourths. That's all I'm looking at right now. I'll look at the rest of the problem later. I'm adding fractions, but I already know I don't have common denominators, so I'm going to turn this fourths into eighths by multiplying this whole fraction by 2. 3 times 2 is 6, 4 times 2 is 8, and then this first fraction is fine. All right. Since I've got one of each number, I've got one negative and one positive, I know that I'm going to have to find the difference between the two, and then once I've found the difference, I'll go back and figure out if my answer is going to be positive or if it's going to be negative. So here we go. I have to subtract the 2. So 1 and 3/8 minus 6/8. 3 minus 6. You can't subtract 3 minus 6, so we're going to borrow. I'm going to take 1 away from the whole number. That reduces it to 0. And that 1 whole that I just took away, I'm going to add to the fraction. I'm going to add it to 3/8. Well, what is another way to write 1 whole? Another way you can write 1 whole is 8/8. And I'm choosing to write it that way since my denominator is 8. So I'm taking 1 away from the whole number, and I'm going to add that 1 whole to the 3/8, and that's going to make it 11/8. So now I have 11/8 minus 6/8. That's the same as this original problem, but now 11 minus 6 is 5/8. I can do that. All right, so the bigger question is, should my answer be positive or negative? It should be negative. The bigger absolute value is 1 and 3/8, and it's negative, so that means my final answer should be negative. All right, last question. Negative 4 and 1/7 minus 5/7. Subtraction, I always change it to adding the opposite. The opposite of 5/7 is negative 5/7, and I keep the first fraction the same. So negative 4 and 1/7 plus negative 5/7. Ooh, when you're adding and both of the numbers have the same sign, in this case they're both negative, you just add the fractions, add the numbers, and then my final answer is going to be negative. So it's negative something. Well, what's 4 and 1/7 plus 5/7? I already have common denominators. That's really nice. 1/7 plus 5/7 is 6/7, and then 4 plus there's no whole number here, so 4 plus 0 is just 4. So your best possible answer is negative 4 and 6/7. Easy one. But remember, for subtraction, add the opposite, and then just use your addition rules. So this is a little bit tricky because you're combining concepts of fractions with concepts of negatives. Take it slow. Hopefully you can use these example problems that I went through to your advantage to help you get through the work. Please reach out if you have any questions. You can reach out on the Google Classroom or on the Hangouts that we have. Otherwise, have fun doing math. We're almost done with week 1, people. Woo!